All right, so we are moving into, we have done, I think we've exhausted our knowledge of triangles at this point, right? And so we are moving into other polygons. The first thing we actually talk about is based off of your knowledge of triangles, though. And so the first thing we are going to look at is angles of polygons. Angles of polygons. So a polygon, first of all, from way back, we have to have 3 or more sides to make a polygon, right? 2 sides is not going to close to make a polygon. Polygons can be concave, convex, etc. So we did all of that at the beginning of the year with polygons. And so now we're going to get in depth a little bit more into their attributes. The first thing is the interior angles. Interior angles. So these pictures are pictures of different polygons. And so you'll see the first one is a quadrilateral, which is a 4-sided polygon. If you connect your vertices to each other, you will get 2 triangles. So I'm already connected from, if I were to take this one vertices and connect to every other one, this one connects it on the side of the polygon, this connects it diagonally through, and this connects it to the other side. So if I take one vertex and connect it to every single other vertex, I will get 2 triangles here. 2 triangles. So what is the sum of the interior angles of a triangle?
360.
360. No. It's a triangle.
180.
180. You're jumping ahead of me. So how many triangles do I have?
2.
2. So what's the sum of this?
360.
360. Let's look at the pentagon. I have one vertex. Connected this one, this, and this. How many triangles do I have? 3. So I'm going to multiply 3 by what to get my interior angles?
180.
180, right? What about a hexagon? How many does that have?
4.
4, right? Heptagon has?
5.
There should be a pattern you're seeing. Octagon has?
6.
6. And so if you look, triangle has 3 sides. There's 1 triangle in it, so 1 times 180. Quadrilateral has 4 sides. There are 2 triangles, 2 times 180. Pentagon has 5 sides. There are 3 triangles. 6 is 4. What's the pattern? What pattern do you see here?
You're multiplying by one number higher than you get first. You take the total sides and you subtract by 2.
Number of sides in my polygon. Subtract 2. That's how many triangles you'll have. Multiply that by 180. That is your interior angle. And that's your theorem right here at the bottom, page 4. Interior angle sum. If a convex polygon, remember convex means it's out, it doesn't cave in on itself, right? Has n number of sides, and S is the sum of the measure of the interior angles, then your sum of your interior angles is going to be 180 times n minus 2, number of sides times subtracted by 2. All right, so look at example 1. The benzene molecule C6H6 consists of 6 carbon atoms in a regular hexagonal pattern with a hydrogen atom attached to each carbon atom. Find the sum of the measure of the interior angles of the hexagon. So it's important that you remember your names and your sides. Okay, hexagon has how many sides? Even if you didn't have a picture? 6. And so if I wanted to find the interior angle here, I would say 6 minus 2. That gives us 4. And I'm going to say 4 times 180. That will give me 720 degrees is the sum of all the interior angles. So if I were to take, when they say sum of the interior, they mean this angle plus that angle plus that plus that plus that. Now, with a regular polygon, all those angles will equal the same. But this works for all convex polygons. So that convex does not mean that it's regular. That's one of the rules of it being regular. But you can have a convex polygon that doesn't have all the sides, all the angles the same degree, right? If it's regular, then you automatically know that they're all the same. But this works for regular and for irregular polygons, as long as they're all convex. All right, let's look at the next example. The measure of an interior angle of a regular polygon is 108. Find the number of sides. All right, so now they're not asking for the sum. They're saying, I want a specific angle within it. I'm giving you a specific angle within it. I want you to tell me how many sides it actually has. It didn't even tell me the sum. It told me one angle, all right? So I should know, it says, first of all, this little term that I just talked about, regular. That word regular just told you all of the interior angles are congruent. They're all congruent, all right? So if I were to take the sum of the interior angles, and I were to divide by the number of angles, I should get one of the angles, right? The entire sum divided by how many angles I have, if they're all the same, that should give me that 108, all right? So the 108 should equal my sum divided by, we'll say, n, number of angles. That equals 108, right? So how do I find my sum? Well, my sum, we just said, is what? N minus 2, the number of sides, times 180, right? So far, so good? All right, so here's what I need to do then. I need to, if I want to get sum by itself here, I'm going to multiply 108 by what? This n. So n will give me sum. So up here, the sum equals 108 times n. Here, the sum equals n minus 1 times 180. If they both equal the same thing, what can I do with them? They both equal the same thing. What can I do to solve? Substitution. So I can take this 108 and I can plug it in for what the sum equals, because I just said that's what it equals. So 108 times n should equal n minus 2 times 180. So how do I solve?
Well, you need to distribute.
I'm going to have to distribute, right? And then I'm going to have to get all of my variables to one side, all of my numbers to the other, right? So distribute this guy. 108n equals 180n minus 360. Variables to one side, so what do I need to do there? Subtract first, then we will divide. All right, so subtract first. What is 108 minus 180? Negative 72n equals negative 360, right? Negative 72n equals negative 360. My final step then, yes, is to divide. Divide, and this actually works out perfectly. N equals 5. So what type of polygon do I have?
Pentagon.
Pentagon. I have a pentagon here. My sides are 5, pentagon. So when they give you one interior angle, you are going to set that up times n, and that equals the n minus 2 times 180. So when they give you the interior angle, multiply that by your number of sides, and that equals the sum of the interior angles. All right, so for example 3, if you turn the page, example, or bottom of that page, example 3, page 405, this is not a regular polygon. How do I know that?
Because there's different angles.
Right, I have x's and I have 2 x's. There's no way those are the same angles, right? However, this is it does meet the requirement of being convex. So because it is a 4-sided figure, I know that I'm going to say 2 times 180 to get what all of the inside angles equal. So what do all of these inside angles equal? 360. All right, so I know they all equal 360, so I can literally just add them up. So I can say x plus 2x plus 2x plus x, right? So how many x's do I have there?
6.
6. I have 6 of those. What is one of those x's equal?
60.
All right, so I can easily find my angle measurement here. A is going to be 60. D is going to be 60. What about B and C?
120 each.
120 each. Very simple. Page 407, 4 through 9. Sum, number of sides, and then just like the example we just did, 2 of each. Let's check your answers here. First one, pentagon, that's the one you all probably have memorized before it's all over, 540. Dodecagon, that was an easy one. You should have multiplied by 10 there because that's a 12-sided polygon. 60 degrees, that's one you might recognize because it's an equilateral triangle. And then 90 degrees, that is a 4-sided, that would be like a square or a rectangle would have 90-degree interior angles. All right, for number 8, you had to find your value of x, and then you had to also plug it in. So T and V were both 46, U and W were 134. And then for 9, you would have had J and M were both 30. K, L, P, and N were all 165. So 8, it's four-sided. So what's your sum of your interior angles for 8?
360.
360. So you have x plus 3x minus 4 plus 3x minus 4 plus x equals 360. So I'm going to combine my like terms. X, 3x, and x. How many x's do I have? All right, so we have 6x, and then we're going to combine -4, and -4 gives us -8.
Oh, wait.
All right.
I subtracted 8 and added.
Yeah, and then you're going to add. All right, 8x equals 368, right? Divide. It will divide evenly now that it's 8 and not 6. All right. So 8 goes into 368 how many times? 46, which is how you get your x. Plug it back in to get your u and your w.
Makes more sense.
All right. Okay. Number 9. How many sides do I have on number 9? 6. So I'm going to say 4 times 180, right? 4 times 180, which gives me what? 720. So all of this should equal 720. So I have 2x, and I'm not going to write it all out because for room's sake here. So I'm going to add all my x's. So 2 and 2 and 9 and 9 and 9 and 9. How many x's do I have? 40. I have 40 x's. And then I'm going to add all my whole numbers here. 30, 30, 30, and 30. Yes, how many do I have?
120.
There we go, 120. Subtract 120. 40x equals 600, right? Divide by 40.
15.
X is going to equal, it's going to equal 15. Your zeros cancel out, all right? And so then to plug it back in, we have to multiply by 2 to get these. That gives me my 30. Then we have to multiply 9 and then add 30 to get my K, L, P, and N of 165. Exterior angles are much easier, actually. What happens with exterior angles, so this is a pentagon with 5 of them. If I were to somehow draw a like 8 or 10-sided figure, then what starts to happen is this spiral starts to occur. And you can actually see it over here on this one. You start to see this spiral happening. They get tighter. So if I were to actually draw these out, you start seeing the spiral. And so what happens with exterior angles, it doesn't actually matter how many sides you have, they will always end up adding up to 360. So they technically will form a spiral. Now, the measure of the exterior angles will get smaller and smaller depending on how many sides you have, right? If I have a pentagon and they add up to 180, those are going to be larger than if I have a dodecagon and they add up to 180. Obviously, 360. 360 divided by 5 is going to be a much bigger angle than 360 divided by 12, right? So if they always add up to that circle, that 360, then it's very, very simple to find your exterior angle. The other thing I want to point out about an exterior angle is that it will always pair up with your interior angle. So let's look at example 4 together first, all right? So how many sides do I have on example 4? 1, how many do you have?
10.
8, right? So I have an octagon, okay? It is a regular octagon, so that tells me that they're all the same angle measure. So they want me to find the measure of an exterior angle and an interior angle. So we'll start with exterior. Exterior is much easier. They all add up to 360. So I'm going to take 360 and I am going to divide it by 8. 360 is what they'll always add up to. Just going to divide by how many sides I have. 8, all right? When I do that, what do I get? 8 goes into 36 4 times with 4 left over. 8 goes into 40 5 times, right? 45 degrees. That's my exterior. Exterior is easy. 360 divided by how many sides you have, all right? Let's do interior. Interior is going to be 180 times what? I have 8 sides, so I'm going to multiply by 6, all right? So 6 times 180 gives me what?
6.
Yep, 600 times 480, so 1,080. And I want one interior angle. That's all of my interior angles. I want one of them. What do I do with that 1080? Divide by 8. Divide by 8. So what's one interior angle here?
135.
135. All right. Now, I'm going to take my 45, and I'm going to add it to my 135. What am I going to get?
180.
That will always happen with interior and exterior angles. All right. They will always be supplementary. Interior and exterior angles of the same polygon will always be supplementary. So if you find one, you can find the other by just subtracting from 180. All right. So if they want the sum of the interior angles, you need to do the sum. If they want one interior angle, you can find the exterior and subtract from 180. You don't have to do the sum. All right. So they're kind of interchangeable because they always are supplementary. So go ahead and find a couple and we will be done. 10 and 11. Six-sided, find the measures of a six-sided. They want interior and exterior, 60 and 120, 18, 20 and 160.